Welcome, ladies and gentlemen, to this video lecture. Let's take a look at this example. So we want to compute the integral or the indefinite integral of ln x. Okay, and we have been using integration by parts. So we are primed into using integration by parts. And remember, integration by parts works when you have the product of two functions. And then you can pass the derivative of one of the functions to the other function. However, we see here we've got a problem. We only have one function. Now there's a little trick. So what we will do is we will write this integral as follows: ln x times 1 dx, and we will view this as a constant function multiplied with that function. And now we also see here this is a derivative, so the constant 1, that is a derivative of just the function that sends x to x, or the identity function. And we will define our f as that. Okay, so let f of x be defined as ln x, then f prime of x is 1 over x, our g prime of x, let's define that as 1, and what is the what function has a derivative of 1? We can use our or just the identity function, so the function that sends x just back to x. Okay, let's see what happens. So then the integral of ln x is equal to integral of g prime x fx dx. Actually, let's write it the other way around. F of x is ln x, and g prime of x is 1, and that is what we had over there. Good. Okay, now we apply integration by parts. This is equal to f of x g of x minus f prime of x g of x dx. And now we're not evaluating this this expression on the left here, since we are working with an indefinite integral, so we don't have bounds on our integral. Okay, so let's see what happens here. So let's plug in everything that we need. F of x is ln x, g of x is x, I'm going to write it like so, minus the integral f prime is 1 over x, and g of x is x dx. X cancels with x, we're left with x ln x minus 1 times dx, which is equal to x ln x minus, and this is x plus c. Okay, and that is it for this example. So now we should be a little bit careful here. We should be a little bit careful here. So this is an indefinite integral, so we should just think about where ln of x is defined. What are we allowed to put in here? And here we see we are dividing by an x. So for this to make sense, let's just think a little bit about if this makes sense. So if we just think about the graph of ln x, it's not defined when x is negative, and it is not defined when x is equal to 0. So this is only defined when x is greater or equal to 0. So let's just add this condition up here. Let that for x greater or equal to 0. Let's add that condition also down here for x greater or equal to 0. Okay. And that is it for this example. I will see you in the next one.